Welcome everybody. This is the Molecular Models Lab for virtual learning. I wish we were together to do our model kits and build three-dimensional shapes, but we will do our best to incorporate this in the virtual setting. You will need to draw molecules on paper. You can either insert one big document or like a page at a time. Please do not go through the trouble of uploading a separate picture for each one. Just put it all together. So it makes it really nice and straightforward. Okay, so what you want to do is go to this PhET simulator for our different shapes. Okay, I highly suggest you click up here to the Duales app and split your screen 50-50 so that you can look at both screens at the same time. You might want to reduce this one down a little bit and angle it over so that you know what to expect. And then you can do the lab on the other screen and split them like so. You want to click on the play button and then on the models like so, and then check molecular geometry, electron geometry, and show bond angle. Molecular geometry, electron geometry, show bond angle. And the cool part is that you can move these all around and it shows you the lovely little bond angle like so. And then it says use the menu in the upper right hand corner of the two bonding atoms and click the X next to it. All right, so you can see that there is just one now, and then you can click and add one back, and you can see that it springs back into life, and you can spin it around and you will write down the molecular geometry right here where it says linear and the bond angle right here, show the bond angle. You'll see that this comes up like so at 180 degrees. When it says to add another atom by clicking the bonding atoms part, you will see that we now have this trigonal planar here. So we have three things in one plane. If you spin it this way, you see they all occupy the exact same plane. It's flat, okay, like so. And a circle is 360 degrees divided by 3 gives them a bond angle of 120 each. Now add a lone pair. When I add a lone pair, it doesn't make it flat anymore. It makes it a pyramid. If I remove that lone pair, it is flat. If I add the lone pair, it is a pyramid. Flat, pyramid, flat, pyramid. And it changes the bond angle also. So you can add your second lone pairs in and see what you get all throughout your inklings up here. Now you can go through and reset the red button and then go over to the second part where again you check your three things and then it says use the right hand corner till there's just one single bond there and then add two double bonded atoms. So there we go. Now we have a double bonded atom, and you can end up seeing that it is still linear with 180 degrees. How fantastic. Okay, so what we're going to do over here is we're going to go to a build a molecule simulation. So again, you can click on this one and drag it over here so you can see that second part open up. And we're going to click the play button and hit on the single one. And you can see over here we have the little, I'm going to zoom out a little bit more so that you can see everything a little bit more clearly. We're going to click on the singles and then you'll need to scroll through the pages here in order to build our different atoms. And I'll show you what to do with the 3D button and the ball and stick. Now you should remember this from class, our Vesper geometries, so we can kind of put a name to the shape that we're going to be building. And first things first, we have to build some water. Okay, so water is H2O. So I'm going to need two H's and I'm going to need an O. And I'm going to bond them together. Awesome. But before I put it in here, what I want you to do is if you build it wrong, you can always unbond them. all right, by clicking on that. But if you go to this 3D portion, you can see our little Mickey Mouse looking molecule is our water molecule. Okay, this is the cloud filling model. This right here is the bond, the structural formula model. So you're going to want to come in here, and if you have colored pencils, that's great. You can draw your oxygen here in the center, and then you can draw your hydrogen and your hydrogen. If you don't have colored pencils, that's perfectly fine. Um, but you have your atoms like so. And then up here we have H2O. It is a special bent shape, which is 104.5 degrees specifically. Okay. And then what you do is you exit this out and drag it in here. You created that one, and then you can go and build the next one, which is oxygen, which is a diatomic molecule. There are two of them. To see the 3D portion, you can see how they are double bonded together. Interesting. In the space filling model, it just looks like a pair of tushies over here. And we're going to have our oxygen double bonded to our oxygen, and this is a linear 180 degree shape. Okay, once you finish filling that in, you will take and drag it in here, and then you can do molecular hydrogen. Oh, I still have my hydrogen over here. You can build your hydrogen. Look at the 3D model. You can see it has that single bond inside. Add it here. And then over on the right-hand side, you can build your hydrogen, your carbon dioxide, and your nitrogen. And you can see they are all there. And you have your CO2, means I need two oxygens. No, that doesn't quite work. You see how it says COO? That doesn't work there. All right, let's see if I can bond it in another place. No, it doesn't tell me anything, so let's try it another way. That's carbon monoxide. Carbon dioxide, good. And then you need to see the space filling model like so, and see the two double bonds. In the space filling, you can see how they're just connected, but in the structural model, you see the two double bonds. And then put that together and build your nitrogen. So there's your nitrogen. It says molecular nitrogen. Look at your 3D model. Whoa, triple bonds. Cool. And pluck that in right there. And yes, you can go on and do your next collection if you would like to, but you don't have to. You can just come down here to where it says the home, all right, and go over to the playground menu. And in this playground menu, you can build these atoms from here. Okay, you have these buckets over here. So let's say we want to build ammonia. Ammonia is NH3. So I'm going to need an N and I'm going to need three H's. 1, 2, 3. Yay! It says ammonia. Look at the 3D model. And you can see how this one isn't that flat thing that we saw before. It is that trigonal pyramid, that triangle shaped pyramid over here. Okay, so if we go back up, this is that triangle based pyramid right here, trigonal pyramid with that bond angle of 109.5. All right, and then we can put together methane. So you reset after each one. Methane is CH4, so you have one carbon. You have 4 H's. And make sure that you attach it. Ta-da, methane. And you can see your space filling model and you can see your structural model. So a nice little way to kind of put those two together. Then you have your dihydrogen sulfide. So dihydrogen means two hydrogens, and I need a sulfur, so I gotta go find some sulfur. Here's a sulfur. Sulfur, hydrogen, hydrogen, hydrogen sulfide. Okay, good. Space filling, orbital structural model. Carbon tetrachloride. I gotta go find some carbon and some chlorines. Oh, there's only two here, so I can't use that set. So here's a carbon and tetrachloride. 1, 2, 3. Fluor, carbon tetrachloride. Always confirm the name to the shape. You can look at the 3D model. Yowza. Or the stick model. That is a tetrahedral shape. Okay. And then you have your dichlorofluoromethane. 1 carbon, 2 chlorines, 2 fluorines. So if you come over here, 1 carbon, 2 chlorines, 2 fluorines. Difluoromethane. Pretty. And then you can build an ethane. So ethane is 2 carbons and 6 H's. 2, 3, 4, 5, 6. Ethane. Can spin them all around. And then there are 2 ways to build butane. So butane is 4 carbons, so you have to go over to the 4 carbon one. 1, 2, 3, 4. And then you have 10 H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's normal butane. And then see if you can figure out another way to build this. Okay, this is the first way. All right, where it has this little chain that goes like this little zigzaggy business. So then break it apart and see if you can build it another way. And since hydrogen only makes 1 bond, take the carbon and bond it someplace else. Aha. And then start filling in your hydrogens. It's the same number, just in a different orientation. Isobutane. And you can see how this one has this central carbon and it has everybody else on the other side. Beautiful stuff, huh? And lastly, bromochlorofluoromethane. So that means you need bromine. Let's see. CH4Cl. I don't think we can do this one with our sets. There's bromine, carbon. Yeah, we cannot. So we're going to delete this one, and that's it. No conclusion needed. Turn it in when you're done.